Okay, now that we've learned a little bit about the properties of acids, bases, and salts, we are now going to get into the strength of acids and bases. When we think about acids and bases, one of the things that we know is that they will dissociate. Okay, what that means is they're going to split apart into ions in water. So all acids are going to split apart into ions in water. When we talk about the strength of an acid, we're talking about to what degree do they split up? What degree do they dissociate? Strong acids will completely dissociate. Okay? The strong acids completely break apart. So if I have, for an example, HCl, I've got hydrogen and the hydrogen ion, which is bound to a chloride ion. Well, if this gets into water, the hydrogen and the chlorine are going to split. They will not be bound to each other anymore. They're going to be free moving off on their own. Every single one of these HCl's will split off like this. Weak acids will only partly dissociate. So an example of that would be my hydrofluoric acid. Hydrofluoric acid is H plus along with F minus. Okay, so these weak acids will only partly dissociate, which means that if I have a big sample of these, what we're going to see is we'll have some of these HFs that are still milling about in the water, and then you'll also have some of the H's and some of the F minuses that broke off. Okay, so in these solutions you'll have hydrogen, fluoride ions, and HF molecules. Whereas in strong acids, as soon as they get into water, they're going to split and you'll only have hydrogen and chloride. You won't have any HCl's left over. Now, with this in mind, be aware that when acids react, the hydrogen ions are lost. So, for example, HCl reacting with zinc metal is going to form a reaction where H2 is formed and zinc chloride joins. So the hydrogen ions are what's lost in acid reactions. Now bases also split apart into ions in water. As an example of that, we have sodium hydroxide is a base, and that sodium hydroxide will divide into its positive and its negative halves. So your sodium, your Na plus ion, along with your hydroxide, the OH minus ion. Strong bases, just like strong acids, that strength refers to their ability to break apart, to dissociate. So strong bases will completely dissociate, just like we saw before. Sodium hydroxide is a strong base. So as soon as this goes into water, all of the sodiums and all of the hydroxides will split up from each other. Weak bases, again, only partially dissociate. Okay, they only partly break apart. So if we're talking about a weak base, let's say, let's say copper. Okay, so we're going to say copper 1 hydroxide, CuOH. What will happen here is, if you can imagine my copper and the hydroxide that it's attached to, copper and the hydroxide it's attached to, copper and the hydroxide. Okay, now these aren't to scale. You'll have several of these copper hydroxide molecules that are still present in solution, but you will have some positive coppers and you will have some OH minuses that are floating about on their own. So that is going to be our weak base. When bases react, hydrogen ions are gained. Okay, so this is something that we need to understand here. If, for example, I have hydrochloric acid and I combine that with my sodium hydroxide, when they come together, what we're going to find is that the hydrogen that's lost by the acid is going to be picked up by the sodium hydroxide. So the end result is this OH attracts the H and makes water. And then what's left over, the sodium and the chlorine, will get together as salt in solution. Now I'll give you a second to go ahead and practice these. I'll assume that you've paused the video and you're coming back to see the solutions now. Hydrochloric acid gives its hydrogen ion when it reacts with a metal. It must be a HCl gives its hydrogen, so that is an acid. Potassium hydroxide takes hydrogen ions when it reacts with H2SO4. It is a base. It takes hydrogen. Sodium hydroxide completely separates into Na plus and OH minus ions in water. It is a strong base. It's strong because it completely separates. Hydrofluoric acid, HF, is a weak acid. An aqueous solution of hydrofluoric acid contains which molecules / ions? So we thought about this before. HF, since it is a weak acid, it only partly breaks apart. So you will have HF molecules present, you will have H plus ions, and you will have F minus ions present in that solution. Now identify the acid and base present in this neutralization. So HNO3, BaOH2, BaNO3 and 2H2O. Identify the acid and the base. Well, the acid is the one that gives its hydrogen. So my HNO3 is going to give away the hydrogen. This must be my acid. The BaOH2 is going to accept that hydrogen to form water. So this must be my base. Barium hydroxide is a strong base. What ions are present in a solution of barium hydroxide? So because we know it is a strong base, we aren't going to have any barium hydroxide molecules remaining. They will completely separate. So you will only have Ba2 plus and OH minus ions present in that solution.